All right, good morning, and today we are going to be talking about how to sketch or graph these polynomial functions. Now, the reason I say sketch/graph is because this will not be a perfect representation of the polynomial. However, we are going to focus on the key points as we identify from the polynomial function to get a pretty good approximation of what this graph would look like. Okay, so we've got our four steps here. Okay, step one, find all the zeros or x-intercepts, and then we decide if they touch or cross. Okay, then we'll plot those. So step one here for this first problem, remember we break each of the factored parts apart and set them equal to 0. So if we look here, I'm just going to close out of this picture so I can zoom in a little more. But if we set x squared equal to 0, square root of that, x will be 0. That is one of our zeros, so I'll put that over here. It's going to have a multiplicity of 2, which means it will touch. Now we'll solve the next one. X minus 3 equals 0. We'd add 3, x would equal 3. So we have a 0 at 3 with a multiplicity of 1. So that one will cross there. All right, so now I'm going to put these on our graph. So over here at 0 and also at 3, we're going to have some sort of points. Now, if we look here, 0 and 3, if you want, you can put like a little t beside this one and a little c beside that just to remind you it either touches or crosses. That is kind of up to you. Okay, now, step 2, it says determine the degree and the end behavior. Okay, so our degree, we look, there's 2 from this, 1 from that, so 2 plus 1 gives us 3. So degree 3, we decide is it positive or negative. And in our case, both of the x's have a 1 in front, which is positive. So positive times positive stays positive. So we know degree 3, so it will be something like this. It will start low, it will end high. That is because it is positive and it is odd. So remember, if it's an even degree, it's going to be starting and ending the same way, either up, up, or down, down. If it's an odd degree, it will start down and end up, or start up and end down. So we know it will start low, it will come up and touch at 0, and then cut back down, and then cross again at 3. Now the final step, we need to find the y-intercept. Final step before we can sketch it. Find the y-intercept by plugging in a 0 for x, and then we'll plot this point. Now in this case, some of you might already know what the y-intercept is, but say you didn't notice. So f of 0, if we plug in a 0, would equal 0 squared times 0 minus 3. So 0 squared is 0. 0 minus 3 is negative 3, but 0 times negative 3 would be 0. So f of 0 equals 0, which means our y-intercept is at 0, 0. We already have that point. So you'll notice if one of your x's is 0, that also is your y-intercept. You actually can skip step 3. Okay, but if you're not sure, just double check. Okay, so now we need to sketch it. Now before you do this, think about it carefully. Okay, so we know it starts low. And notice it's going to come up and touch at that 0, cut back down, and then go up and cross at 3. So I'll do this in red just so it stands out. And not everyone's will look exactly the same. That's okay. This is an approximation. Okay, so we come up and we touch, and then it cuts down, and then it crosses here. We need to have an arrow on each side. As you can see, the end behavior represents what we thought it would. It touches at 0, it crosses at 3, so we are good. Now, something to remember, if this is a polynomial, in order for it to be a function, it needs to pass the vertical line test. So we just need to make sure wherever we start, we are always moving to the right. We can't cut back. If I cut back, what I mean by that is if I start here and I cut back like that, that is no longer a function. That's the problem. So example 2 here. Once again, first step is finding our zeros. Okay, so to do this, we take each factor and set it equal to 0. So negative 3x equals 0. X will equal 0. So one of our zeros is at 0. multiplicity of 1, which means it will cross there. Okay, the next chunk, x minus 4 equals 0. X equals 4. So 4 with another multiplicity of 1, it will also cross there. So I'm going to put a dot at 0 and a dot at 4. Okay, we'll cross both of those. Now, we got to find our degree. Step 2, find a degree. Degree would be 2. If you're not sure why, there is both 1 here and 1 here. Added together, that's 2. Now, this leading term is a negative. This one's a positive. Negative times a positive stays negative. And for our graph, if it's degree 2, that's even and it's negative, so they will both be facing down, both ends. Now, the final thing we need to do, which some of you might know, we don't actually have to do this step, but we need to find where our y-intercept is. So once again, if you notice what it is already, that's great. If not, plug in 0, and you would have negative 3 times 0 times whatever 0 minus 4 is. So negative 3 times 0 is 0 times negative 4. That's still going to be 0, so our point will be at 0, 0, which we already have that plotted right here. So once again, it's going to start low, go high, and then end low, because it crosses at both those points. So this will not be perfect, but we want to do our best. So we know it starts low, it crosses at 0, and then it comes back and crosses at 4. Something approximately like that. Okay, once again, is this perfect? No. Is it very close? Yes. It highlights the important features, where it starts, where it ends, and the places it crosses 0, our y-intercept. Okay, so take a look here at example 3. What we need to do on example 3 is, once again, figure out what our zeros are. Now you might notice on example 3 here, there's a negative 2 out front. Okay, we don't need to worry about that when we're finding the zeros, because there's no x with it. So let's deal with the x plus 1 first. So x plus 1, I'm going to set that equal to 0. Then x would equal negative 1. So our first 0 is at negative 1 with a multiplicity of 2, which means it will touch there. Now our second one, x minus 3 equals 0. So x will equal 3. So 3 with a multiplicity of 1. So it will cross there. So negative 1 and 3. Now you might notice there's not a 0 at 0. So that means that is not our y-intercept. We need to find our y-intercept. On this one, we actually will have to. But first, let's find our degree. So this will be degree 3. If you're not sure how we got that, nothing for the negative 2. There's 2 here and 1 there, so that's degree 3. And positive, positive, but there is that negative 2, and so that will become negative. Okay, that tells us it's going to start high and end low. Odd degree means it'll be opposite, and negative means it goes down. Okay, now, as we said, we need to find what our y-intercept is. So f of 0 equals, and then it's negative 2 times 0 plus 1 squared, and then 0 minus 3. So another way, if we simplify, negative 2, 0 plus 1 is 1, 1 squared is 1, and that becomes negative 3. This will all multiply to positive 6. So our value is at 0, 6. So I'm going to go ahead, up here I put that dot at the y-intercept of 0, 6. Now once again, I would like you guys to think visually, map it out before you actually draw it. So we know it's starting high, comes down, it touches at negative 1, goes back up through that y-intercept, and then comes down and crosses at 3. So do your best. It touches at negative 1, goes all the way back up to 6, and then it comes down and crosses. Okay, just try to make it as smooth as you can. The key thing, we have to keep moving from left to right. Make sure it constantly passes that vertical line test. So 2 more to do. Example 4 here. Once again, we are going to solve for our zeros. So each chunk, x squared equals 0. So x will equal 0. As many of you know, that means that is a y-intercept. This is a multiplicity of 2, so it will touch there. Then we do x minus 2 equals 0, so x will equal 2. This is a multiplicity of 1, so it will cross there. X plus 3 equals 0, so x equals negative 3. And once again, a multiplicity of 1, and it will cross there. So negative 3, 0, and 2. Now we need to find our degree. So this one will have a degree of 4. And each of the leading coefficients is positive, so it will stay positive. Degree 4 is even, positive, so they will both face up. It starts high and it ends high. Now, to find your y-intercept, we already know if one of the zeros is 0, right here, we already have it marked. Now, once again, if you weren't sure on that, you could plug it in. F of 0 equals 0 squared, 0 minus 2, 0 plus 3, but we know all of that will come out to be 0. So 0, 0 is our y-intercept. So once again, it's going to start high. It's going to come and cross at negative 3. Then it's going to touch at 0, and then cross at 2. So if we start high, cross, touch, cross. And is that perfect? No, but it's a pretty good approximation. Okay, so one final one will do. This one, once again, we're going to find our zeros. That 1/2, it's just a leading coefficient. We don't need that. There's no x with it. So each of these, x plus 4 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So we'll get x equals 2, x equals negative 2, and x equals negative 4. And each of them is multiplicity of 1, which if they are multiplicity of 1, then we know that each of them will cross. I'm just going to put C, C, C. You can start abbreviating C instead of cross and T for touch. So negative 4, negative 2, and 2. And we will need to find our y-intercept. Our degree is 3, and once again, all the leading coefficients are positive. So we know it stays positive, which means it will start low and end high. All right, and to find our y-intercept, we plug in f of 0, so 1/2 times 0 plus 4 times 0 plus 2 times 0 minus 2, so 1/2 times 4 times 2 times negative 2. 1/2 of 4 is 2, 2 times 2 is 4, times negative 2, that gives us negative 8. So our answer, 0, negative 8. So down here, 0, negative 8, I put a dot, that is where it will go through. So we know it will start low, come up, cross, then go through there and cross again at 2. So it starts low, cross, and crosses 2. Something like this. Okay, so if you don't understand this, try to watch the video maybe a second time. We will continue to work on this the rest of the week, but it is something we need to get down, maybe a little bit difficult. So continue working hard. Let me know if you need anything, and I hope you have a great day.